Welcome to Unit 5, where we're going to be talking about bonding and nomenclature, ionic and metallic. We're going to be naming and writing ionic formulas. This video will focus on writing those ionic formulas. You notice how the word ion is in ionic? It's because it's made up of ions, both positively and negatively charged particles. One of the first things we need to focus on is Lewis dot structures. Lewis dot structures are used to represent valence electrons. Remember, elements have somewhere between 1 and 8 valence electrons, 8 being the most. We also need to follow Hund's rule, which tells us that each electron is going to be alone before it gets a buddy. So let's do some practice together. Look at your periodic table. How many valence electrons does sodium have? It has 1. So we just put 1 dot next to it representing that 1 electron. What about magnesium 2+? Well, regular magnesium has 2 valence electrons, but that 2+ means they went away, so it doesn't have any. No dots for magnesium 2+. Aluminum 3+. Aluminum has 3 valence electrons, but the 3+ means they went away, so aluminum 3+ doesn't get any dots either. Silicon is right next to aluminum. Silicon should have 4 valence electrons. And since we haven't put a charge on it, we need to put them on. And we're going to put them on each side of silicon. 1, 2, 3, 4. As we continue moving over on our periodic table, you should figure out that phosphorus has 5 valence electrons. And we're going to put the 1, 2, 3, 4, 5. You see, I buddied those 2 up because I'd already used all my other sides. When it comes to sulfur, it has 6 valence electrons, so we arrange it like this, where 2 of the sides are doubled up and 2 of the sides are left alone. Chlorine -1 tells us that it has gained 1 valence electron from its normal amount. Well, chlorine normally has 7 valence electrons, so if it gained another one, that's 8. So we're going to put 8 dots on chlorine, 2 on each side. Argon also has 8 valence electrons, so we're going to arrange it in the same way. Pretty easy, right? If you have questions, make sure to bring them tomorrow. So let's talk about chemical bonds. They are defined as forces of attraction that hold 2 atoms together and allow them to function as a unit. They are formed because atoms will be more stable and able to obtain an octet, those 8 valence electrons that they want to get. So there are some different types of bonds. There are multiple types of bonds possible, and they are determined by electronegativity differences. Yes, that periodic trend is coming back again. We will determine the type of bond by which elements are present. A metallic is going to be between 1 or more metals. An ionic bond, what we're focusing on today, is between a metal and a nonmetal, possibly also a polyatomic ion. And a covalent bond, which will be in our next unit, are between 2 nonmetals. Last is an acid, which we'll be doing after covalent bonding, which is between hydrogen and an anion or polyatomic ion. So this is a great look ahead. A little bit more on metallic bonds. So metallic bonding is the force of attraction between valence electrons and the metal ions. It is the sharing of a sea of electrons between many positive ions where the electrons act as a glue, giving the substance a definite structure. Some examples: aluminum, gold, silver, copper. So some review for you that we've covered in previous units. The octet rule, and that is an element will gain or lose or share electrons in order to gain a full octet, 8 valence electrons. Metals, they lose electrons and form cations. Nonmetals gain electrons and form anions. A monoatomic ion is 1 element with a charge. And a polyatomic ion is a group of elements with an overall charge, but it functions as a unit. Common polyatomic ions will be given to you, and this is the ones that you will receive. So you can see all of these different ones. You do not have to memorize them. I will provide you with this table on tests. We also have our charges that you still need to have memorized. Remember, we go 1 plus, 2 plus, 3 plus skip, 3 minus 2 minus 1 minus zip, and then you need to remember that silver is +1 and zinc and cadmium are +2. All the rest of these have a variable charge, which we'll be getting to later in this presentation. So as far as ionic bonds are concerned, they form between a metal and a nonmetal ion. Ionic bonds are formed by the transfer of electrons, so they are not being shared. One completely gives its electrons to another. A binary ionic compound is made of 2 different elements, and a ternary ionic compound is made of those 2 different elements where there is a polyatomic ion present. A formula unit, like MgCl2, is the lowest ratio of ions in a compound. This is why we simplify subscripts. So we wouldn't write that Mg2Cl4, for example, because that could be reduced by 2. We always want to write it in its lowest form, just like simplifying fractions. So how ionic compounds are formed? The metal loses electrons to the nonmetal and becomes a cation. The nonmetal gains electrons from the metal and becomes an anion. Positive charges are very attracted to negative charges, which is the type of electrostatic force of attraction, which we call ionic bonding. So essentially we have the metal that is now has a positive charge, the nonmetal that now has a negative charge, and since opposites attract, they are coming towards each other in an ionic bond. When the cation and the anion form an ionic bond, they arrange in a 3-dimensional shape that we call a crystal lattice. There are charged particles present, but the compound has a net charge of 0 since they are balancing each other out. So ionic compounds are held together by an electrostatic force, as I already said, and these units stick together in that crystal lattice structure. And this is what I'm talking about. They form some sort of way that they are attracted to each other, like you see here. This is actually sodium chloride, NaCl. So our properties of ionic compounds. They are electrically neutral, meaning they have overall no charge. They have a high melting point, so they have to get very warm to melt. And that's because it requires a lot of energy to break ionic bonds. They can be brittle and crystalline, so easy to break, and often are going to be in some sort of crystal-like structure. Many dissolve in water. They are soluble. Solid ionic compounds do not conduct heat or electricity. And they are electrolytes, which means they do conduct electricity when they are dissolved in water, which is different than them being melted. So as far as writing formulas for ionic compounds go, our rules are ions are given a subscript to indicate the amount of that ion present in the compound. When adding a subscript to a polyatomic ion, we need to use parentheses. You saw this before when we were learning to count atoms. So chemical compounds must have a net charge of 0. Both the positive ions and the negative ions must be present, and their charges will cancel each other out. So you need to find the charge of your cation and your anion. And then you're going to crisscross without the sign. So you take your cation, and it's going to get whatever that charge of your anion was. You're going to take your anion, and you're going to put whatever the charge of the cation is. If the charges are 1, you don't write the charge. If you have more than a 1 of a polyatomic ion, once again, you must use parentheses. And then you're going to simplify your subscripts if necessary. I know that sounds a little overwhelming, but you're totally capable of doing it. Let's look at it together. So in order for ionic compounds to be electrically neutral, the sum of the charges has to equal 0. So let's look at aluminum oxide. So we have aluminum, which you know from your periodic table has a 3+ charge. The oxide stands for oxygen, which you know from your periodic table has a 2- charge. So we get rid of the charges, and then we just move the numbers to the other side. So we get Al2, which came from the 2 on our oxygen, O3, which came from the 3 on our aluminum. And you can always check these by seeing if you have a sum of 0. So 2, that number there, times 3+ is going to get us +6, plus 3, that number down there, times -2 is going to get us -6, which equals 0. That's just a way of checking your work to make sure you did it right. All right, so if we have sodium and chlorine, sodium has a +1 charge, chlorine has a -1 charge, they just become NaCl. We don't put the ones in there, nice and simple. What about magnesium and chloride? So you should be able to look at your periodic table and know that magnesium has a 2+ charge and chlorine has a 1- charge. So when we crisscross, bring things over, the magnesium gets that 1 charge there, so we don't write anything, and the chlorine is going to get that 2 from over there. Just like that. What about lithium and nitrogen? So from your periodic table, you should see that lithium has a +1 charge and nitrogen has a -3 charge. So when we crisscross, we get lithium with the 3 and nitrogen all on its own. Let's try calcium and sulfur. So look on your periodic table. What charge does calcium have? What about sulfur? So they both have a 2 charge, calcium 2+, sulfur 2-. And when we crisscross, you might be thinking that's Ca2S2, but that can be simplified. So it gets simplified to CaS. Let's try one with a polyatomic ion. We have barium, Ba, and we have hydroxide, OH. Barium, according to your periodic table, has a -2 charge, and hydroxide, according to our polyatomic ion table, has a -1 charge. So when we crisscross, that 2 ends up on the hydroxide, so we have to put parentheses around it so everyone knows that that 2 applies to the whole hydroxide, not just one of the parts. Told you, pretty simple. I know you can do it. So why don't you pause this video, pause it, and practice these on your own, and then come back to see how you did. All right, so if you crisscrossed calcium and chlorine correctly, you should have gotten CaCl2. If you crisscrossed sodium and sulfur correctly, you should have gotten Na2S. Now, as far as lead 2, that 2 told you what the charge on lead is, because lead is one of those ones that we don't have a charge memorized for it. So the number in the Roman numerals tells you the charge. If you need to pause this video to go try the later one, to try this one again, do it now. So we know that lead has a 2 charge, and phosphorus, when you look on your periodic table, has a 3 charge. So when we crisscross, we get Pb3P2. Calcium and sulfate, sulfate being one of those polyatomic ions. I hope you rewound the video to find the formula and charge on sulfate. CaSO4. Now you may be saying, calcium has a 2 charge, sulfate has a 2 charge, where are the 2's? They've reduced away, we simplified them. Magnesium and nitrogen are Mg3N2. Aluminum and oxygen are Al2O3. Lithium and chloride should be LiClO2. Iron 4, so that had that 4 charge on it. When with the phosphite, 4 goes outside the parentheses, and the 3 charge from the phosphite goes with the iron. And then beryllium acetate becomes Be, then our parentheses, C2H3O2, with our 2 from our beryllium charge on the outside. So that's all there is to formula writing from ionic compounds. I know you can do this, so come to class tomorrow ready to practice.